Okay, class, so in our last video we talked about dimensional analysis, and that was where we used math to convert units, and we'll be using that a lot today when we talk about the mole. But the mole is a foundational topic that we learn in chemistry that will play out throughout the rest of the semester and a lot of the school year. So it's really important to get this topic down, but it can be kind of complicated. You'll see over a couple slides from now when we start doing math with the mole, I think that's where it gets kind of tough. The concept of the mole, though, I think is relatively easy to grasp. And the concept is that the mole is a specific unit that we use when we're counting atoms. And we talked about atoms are these really small things. And so even if we have the amount of atoms that can fit on the head of a pin, there might be thousands, even millions of atoms just in that really tiny area. So we're not just going to count them one at a time. So we use a new type of unit called the mole to measure how many atoms that we have. Now think about it this way. Think of you live in a world where there is only inches, okay? Feet is not a thing. You only have inches. And you are measuring your room, and you need to know what the area of your room is, but you only have inches. So could you imagine that number? It would be a really big number because inches are relatively small compared to the size of your room. Therefore, feet would be a way better measurement, okay? So if you lived in a world with only inches, you might come up with another measurement that's bigger that would make it to where when you measured your room, that number would be more manageable and you could understand it easier. So that's what the mole is. Avogadro came up with this number, and essentially what it is it's a number where you have 6.02 times 10 to the 23rd atoms in every 1 mole of a substance. So for example, if you have 1 mole of copper, that means that you have 6.02 times 10 to the 23rd atoms of copper. Okay, so what this really comes down to is we will have to learn how to convert different amounts of atoms to moles. And we'll also have to be able to convert from moles to atoms. So in this first problem here, we're just going to follow dimensional analysis. We're going to start with what we know. And we know that we have 3.01 times 10 to the 23rd atoms of silver. So we draw our fence and our rail here. And we know that on the bottom, we're going to have atoms because we know that atoms will cancel with atoms. And what we're trying to find is moles of silver. So we put moles on top. And we know that a mole is a much bigger unit. For every 1 mole, we actually have 6.02 times 10 to the 23rd atoms. And so then we put that in our calculator. We take 3.01 times 10 to the 23rd, divided by 6.02 times 10 to the 23rd, and we get 0.5 moles of silver. Now the other one here is almost backwards. The only difference is we're looking at magnesium instead of silver. So we start with 0.5 moles of magnesium, and on bottom we put moles because we want our units to cancel, and on top we are trying to find atoms. Moles gets the 1 because it's the bigger unit, and we know that for every 1 mole there are 6.02 times 10 to the 23rd atoms. Ran out of space there. So we plug that in our calculator, and we get 3.01 times 10 to the 23rd atoms. And if we look here, our units cancel. Moles of Mg cancels with moles of Mg. We're left with atoms of Mg. So that looks pretty easy, okay? Both of those problems, pretty easy to figure out, pretty easy to type into our calculators. And we see that it doesn't matter what element we're talking about. If you're counting atoms, you can use the mole. So on this next slide here, we're talking about moles as relative to mass, because on the last slide we saw that if you have the same amount of moles in each of your substance, you're going to have the same amount of atoms. It doesn't matter what the atom is. But we learned a couple videos ago, a couple units back, that each of the atoms on the periodic table, each element has its own molar mass, which means that if you have a mole of one substance, it's going to weigh different than a mole of another substance. I would have you think about if I have a dozen elephants and a dozen rabbits. Obviously, I have 12 of both of those things, but the dozen elephants is going to weigh a lot more than a dozen rabbits. So that's kind of what is happening when we're looking at the masses of elements on the periodic table. Some of them are much heavier than other ones. So to find the mass, we need to look up on the periodic table, and we calculated the average atomic mass a couple videos ago, and we talked about that. So atomic mass units, that is how many grams you would get in 1 mole of a substance, or you can get that number from the periodic table. That's saying that the average atomic mass is the number we get for AMUs. So if we look at sulfur on the periodic table, and we look below the symbol there, we see a number with a decimal, and that's the calculated average atomic mass. That's telling us how many atomic mass units we have in 1 mole of that substance. So specifically for sulfur, we see that that number is 35.45. So I'm just going to write that in here, 35.45. And in 1 mole of sulfur, we would also have 35.45 grams of sulfur. So in 1 atom of sulfur, we have 35.45 atomic mass units, and in 1 mole of sulfur, we have 35.45 grams of atomic mass, or 35.45 grams. So let's do a little bit of practice. What is the mass in grams of 3.50 moles of the element copper? So I've got 3.50 moles of copper. And this time, instead of going from moles to particles, we're going from moles to grams. So that's going to look a little bit different. We're going to use our periodic table for that. So I've got 3.50 moles, which means I'm going to put moles on bottom to cancel with moles on top. And we are going from moles to grams, so I'm going to put grams on top here. Now, in every 1 mole of copper, I'm going to look at my periodic table, and I'm going to see that for every 1 mole of copper, I have 63.55 grams. So now I'm going to plug that into my calculator. And I get a mass of 222.4 grams of copper. My next problem here is similar, it's just going backwards. I'm starting with grams and finding moles. So a chemist produced 11.9 grams of aluminum. How many moles of aluminum were produced? I start with 11.9 grams of aluminum. And I'm going to put grams of aluminum on bottom, and I'm going to put moles of aluminum on top. And for every 1 mole of aluminum, I'm going to have 26.98 grams of aluminum. I plug that in my calculator, and I get that in approximately 11.9 grams of aluminum, you should have 0.44 moles of aluminum. Now here's our mole roadmap, and if you'll notice these portions here on the side, those have our conversions that we've just talked about. If you're converting from the amount of element in moles to number of atoms, then you're going to use our number 6.02 times 10 to the 23rd. But if you're going from the amount of elements in moles to the mass of elements in grams, you have to use the molar mass on the periodic table. The only thing is, down here at the bottom, this red one, we have to be really careful because these problems are two-step problems. You can't go straight from this one to this one, or from this one back. Essentially what's happening is you have to go through all of these steps up here to get to mass from number of atoms in an element. Or to go from mass of an element to number of atoms, you have to go all the way around. Okay? Down here, this box in red, that's just showing both steps in one. So it's going to be a two-step problem when we come to these conversions. And you'll see what that looks like on the next slide. So it says, what is the mass of 2.04 times 10 to the 35th atoms of bromine? So we're going to start with what we know. We know we have 2.04 times 10 to the 35th atoms of bromine. Well, we're going to have atoms on bottom, and we are going to actually put moles on top because we're going to have to go to moles before we can go to mass. And for every 1 mole of bromine, we're going to have 6.02 times 10 to the 23rd atoms. And then we're not done because it's asking for mass and we've only gone to moles. So we're going to put moles on the bottom again. And we're going to put grams up top because grams measures mass. And in 1 mole of bromine, we have 79.9 grams. So we're going to plug all this into our calculator and then multiply 2.04 times 10 to the 35th by our 79.9, and then we're going to divide that by 6.02 times 10 to the 23rd. And our final answer here, I'm actually going to write it up top, is 2.71 times 10 to the 13th power. And that's how many grams that we're going to have. So in 2.04 times 10 to the 23rd atoms of bromine, we have 2.7 times 10 to the 13th power grams of bromine. This next one says, how many atoms are in 10.5 grams of calcium? We're going to start with what we know. We have 10.5 grams of Ca. We're going to look on the periodic table here. Got grams of Ca on the bottom, moles on top. And in 1 mole of Ca, we are going to have 40.08 grams. And I got that number from the periodic table. But we're asked about atoms. So we have to go from moles of Ca back to atoms. And for every 1 mole is 6.02 times 10 to the 23rd atoms. We plug all this in our calculator. And we get 1.58 times 10 to the 23rd atoms. And that is it. That is how we convert from mass to atoms and from atoms back to mass. And see how that's a two-step problem? We have to go all the way through both steps on the mole roadmap to move from number of atoms to mass and from mass to number of atoms. These problems back here are single step because these problems are just going from mass to the amount of element in moles and from moles to the number of atoms of an element. So anyways, thank you for watching and have a good night.